Alright guys, we're back on our day 3 task. There's not a lot more going on today. We're going to look at hardening the devices, but pretty much there's not a whole lot of options going on with packet tracer. So what we're kind of limited to is we're going to add an enable secret, username, password, and we're going to generate crypto keys, enable SSH. We're going to create an ACL that's going to be applied to the VTY lines to enforce restriction on IP access to network devices, and then we're going to create a method list with AAA to enforce local login. And that's pretty much what we're going to look at. We're going to, by the end of it, we're going to create a script that we're going to apply to all the other devices, because once you build out one, it's going to be the same process for scripting this out for the remaining devices. And then we're going to verify, show at the end that our admin PC is the only one that's able to log into all the routers and switches on the topology. So we'll go and kick it off with AS1. We're going to drop into CLI, go to global config. So first off, we're going to create our enable secret. So we're just going to do enable secret Cisco. We're going to keep very basic passwords. Username is going to be Cisco. And then we're going to do privilege 15. So typically on a local admin, you'd set privilege level 0 if you were if you had a TACAC server that you could log into or use to authenticate you. But we don't have that, so we're just going to work off the local admin. So we're going to give the local admin privilege 15, which is going to be max privilege levels. And then we're going to do secret Cisco 123 bang. Next up, we're going to make steps in configuring SSH or setting up SSH. So there's a couple things that we got to do. Whereas we just created the enable secret, username, password. We have to give the device a domain name and generate crypto keys, and then once we generate the crypto keys, it should automatically enable SSH. So we'll go ahead and start with creating the domain name. So we're going to do IP domain name, and then we're just going to keep it basic and do lab. And then we'll jump into creating crypto keys, crypto key generate RSA. So once again, kind of limited on command structure for packet tracer. Typically, you would have a option for modulus 2048, and so you can just do creating your key in one line, and then it'll generate after you do the one line. But this instance, you have to send the command in packet tracer as just crypto key generate RSA, and they'll ask you what your key size, what key size you want it to be. So we're gonna do 2048, and once the key's generated, there you see SSH2. Y comes up as SSH 1.99. We're not sure, but SSH2 is enabled. From here, we're gonna go ahead and create our ACL. So we're gonna do IP access list standard. Now we can either give it a number between 1 and 99, or we can name it. We're just gonna name it admin, because I like descriptions, as it can help identify what that ACL is meant for a lot more. And we're only going to do one permit statement, because we only have one admin subnet, which is the 10.10.100.0/24. So we're going to run a permit statement of 10.10.100.0, and with ACLs, you have to do a wildcard mask. It's not your standard subnet mask. So you got to do, just like EIGRP and OSPF, you're going to do 0.0.0.255 for this particular subnet. And then we're going to end our ACL with a deny statement. So we're going to do deny any and send that. Next, we are going to hit our console line and VTY line. So we're going to go line con 0. We're going to tack a password onto the console port. So we're just going to do password Cisco. We're going to do logging synchronous. Then we're going to jump into our VTY line. So line VTY 0 to 15, because we only have it's a total of 16, but it starts at 0, goes to 15, so a total of 16 VTY lines on this specific model. And then we're going to do also logging synchronous here. We're going to do, we're going to set a password as well. It's just going to be Cisco, just like how we did with the console port. Then that ACL that we created, we're going to go and attach here, and this is what's going to enforce IP restrictions on what IP range can log into or SSH to network devices. So we're going to do access class, and then we're going to call out the ACL number or name that we created. In this instance, we created a name, not a number. So we're going to do access class admin, and then we have to define direction of where we want to place the ACL. Do we want to enforce the traffic coming in or traffic going out? So we want to enforce it going in, so anytime a device makes a connection into our switch or router, it's enforcing that ACL policy saying, hey, I only see 10.10.100 as permitted, everything else is denied, so we're going to do in. And then the next thing we're going to do is transport input SSH. Basically, at this point, this says that we're not going to allow any telnet connections. We're only going to allow SSH connections into our VTY lines. From here, we are going to jump to creating our ACL method list, or AAA method list, excuse me. Not a whole lot we can do with this, unfortunately, in Packet Tracer, but we can enforce local login to where anytime someone logs into a network device, it's going to enforce local login. And then because it's only going to enforce local login, we're also going to have it enforce the enable secret as well. So first thing we're going to do is we're going to enable AAA new model. Then we're going to do AAA authentication. We're going to use contextual help, just see the different options that we have. So we first want to write our method list for the login. So we're going to do AAA authentication login. Let's do contextual help. So here's where you can either define your method list for authentication in the fact of naming it, or can you just use the default? Next, we are going to. We don't have any group servers, so we're not going to use server group. Typically, if you had more than one server, like more than one radius or TACX server, you use a server group so you can define out more than one. But we're just going to do local since we're enforcing local login. And that will be it for this line. For the next line, we're going to do enforcement of the enable secret. So AAA authentication enable. And we're going to default and enable again. Now, you could have done none there, and it would have skipped past asking for the enable secret and went straight to privilege mode. But like I said, in this instance, since we don't have a AAA server to actually enforce authentication and authorization, I'm going to do a two-step verification in the sense of like you put in your username and password as your local login. This is what we created with the Cisco and the Cisco 123 bang. And then the second step is that once you have that verification, it's going to ask you for the enable secret. So almost kind of like I wouldn't say it's not two-factor, but it's two passwords that you have to pretty much put in before you can actually get to privilege mode and start actually running commands. So next command we're going to do is going to be, I believe it's a AAA authorization command. Yep, AAA authorization exec default, and then we're going to do if authenticated, and then send that one, and then we'll go ahead and do AAA authorization network default if authenticated. And I don't believe we have any accounting commands we can actually really apply to this thing because we don't have the AAA server set up. I'll tab it out, just see what our options are. Start, stop. Start, stop. See, we don't have any group servers, so we can't. There's not much we can really do. We don't have a radius server. We don't have a TACX server, so we're just gonna kind of leave that line as is. We're gonna. Typically you would want to apply accounting, so any command that you would run on a switch, any user that logs into the switch, whether it be through console, whether it be local admin, whether it be a TACX login, radius login, you want to account for all the commands that people are putting in. So it's kind of like a change log, you know. Any change, any command that is run on the switch, it goes back to the accounting server. That would be your AAA server. to log all those commands that are run on the switch in case, if a switch goes down, you want to know what happened to it. You want to know who did it. You want to know what login actually initiated those commands. If a trunk goes down, if a routed port goes down, if for whatever reason you can't reach the switch, you want to have an accounting of a log of certain commands that happen, and even like debug logs and whatnot. So pretty much, I think there's one other thing that we do need to do. So we're going to go back into the line VTY 0 to 15. This is where we're going to set our login method. So login authentication default. It's going to use the default method list to authenticate users logging in through the VTY lines, and we'll jump into the console, and I believe we got to do it there as well. So we're going to do login authentication default. So it's going to enforce the default method list for both console and VTY lines, and I believe that should be that. We will test our admin machine real quick just to make sure we can get into the switch. So we'll go to desktop, command prompt. And so typically in a real world situation, you'd have like a terminal emulator like PuTTY, Secure CRT, TerraTerm, something of that nature. Obviously in Packet Tracer we don't have that option. So you actually can, from your Windows command prompt, or even I would believe a Linux terminal, I've never tried it myself, but I'm sure you can do it. You can actually log in from your Windows command prompt to a switch that you've enabled SSH to. So all you have to do is just call out the protocol that you want to use. You can do SSH or Telnet. If Telnet is enabled, I would hope that you don't have Telnet enabled in your network. So in this scenario, we're just going to do SSH. So SSH and then -L for login, and then you'd put the username in for your login, and then the IP target of the device you're trying to log into. So AS1 would be 10.10.5. I believe it's 36. Okay, so it prompted me for a password, so that's a good sign. Logging in, and there we are with enable mode. So we're going to do enable, and it should prompt me for the enable secret, which it just did. And now we are in privilege mode and we can run commands. Alright, so as I mentioned before, what we just did here, we're going to do on all the devices. So rather than me typing out on every single device, I'm going to create a script in Notepad of everything that we just did, and then we're going to paste it into all of our devices. So just kind of bear with me. We're going to kind of walk through. One more command. So if you notice, we're not going to see it here because we did the enable secret, but maybe if we scroll down to the VTY lines. Yep, you see our passwords are in plain text. We don't want any shoulder surfers to be able to see any of our passwords. Now, you saw with the enable secret and our username, they are encrypted. It's because we use the secret command. Unfortunately, on the console port and the VTY lines, we don't have that option. So the command that we are going to run real quick is going to be service password encryption. And it's a very light level encryption. It's arguably not even really that highly encrypted, but you'll notice that once we show run again and we go down to the console port and the VTY lines, you'll no longer see that password in plain text. So just a command that you should run anytime you put passwords on your switch or router, regardless if you're using the secret command or not. So we'll move on to scripting again over in Notepad. So running from the top, I'm going to copy that service password encryption. Then we're going to copy the enable secret. So technically, you can copy this hash password right here, and it should take on the switch. However, for this particular scenario, we're going to do it in plain text. Scrolling on down to AAA. So even though AAA is further up in the running config, we are going to apply that last. And the reason why is that if you apply this before you set a username and password on here, you are going to lock yourself out of the switch. So it's best just to apply that last. And we are going to grab the domain name that we created so we can enable SSH. We're going to do, sorry, I meant to do bang. We're going to do crypto key generate RSA. Problem with this is that it's going to probably prompt, it will prompt us for what key size we want to use. So we'll have to probably split this, this script up in two sections. Because unfortunately, like I said, with Packet Tracer, it doesn't give you the option to do the modulus 2048 or modulus whatever your key size is. So it's gonna end up breaking up the script for us. So we'll go ahead and space it down a little bit, and username and password, we're gonna copy that. Actually, we can really do that right here. There's no like order of precedence to some of this stuff. The only thing I'd say that's major important is when you're applying SSH and when you do AAA. AAA, I always recommend doing last. All right, scrolling on down, we can get past the ports. The next thing we really gotta look at is the ACL, which we can also apply that before we apply the crypto key. And same thing with our console and VTY lines. Once again, we're going to take the passwords for the console and VTY lines and apply them in plain text rather than hashed or encrypted. Alright, so this part we can apply first, and then once it generates the crypto key and asks us what the key size we want it to be, then we'll come back and apply AAA. So we will go and give that a run on DS1 switch. So I'm going to take my notepad. Know that you have this. I'm going to move it over into another screen that you guys won't be able to see, just so my windows don't keep going away. So I'm going to move this over. Actually, this is in a virtual machine, so never mind. Alright, so we're going to hit the return button and paste. $20.48. Okay, so a little mistake I did here is the login authentication default. That's going to have to be applied after our authentication list method has been applied. So we're going to put that down here. We'll go ahead and get rid of this. No harm, no foul there. We'll just go ahead and paste in the AAA. Once again, made another mistake. So line VTY 0 to 15, and then it should do it. There we go. All right. Let's move on over to DS2. Like I said, we're just going to do this for every single network device that we have here. No point in typing out all the same commands on all the same devices. So just bear with me. Office core. So if you never knew this, the reason why I have the exclamation points here is that if you've ever been familiar with like programming, these are kind of like comments. You know, you could put a command before, like after this, and it won't recognize it. I mean, it'll comment it out basically, so it won't enter it into the command structure. But the other thing too is that like when you're sending a string of commands like this, right? So say if I only wanted to do this. If I have the bang at the end, the exclamation point, it's almost like hitting enter. So it's typically why I do these exclamation points in between every single one of my command sets and whatnot. Some of you may have already known that, but not everybody knows that. So did I do AAA on that? Yes, I did. Almost there, just got 2 more devices to go. Finally, LS1, and then like I said, we'll test having the admin machine go to a few of the other devices. We're not going to hit every single one of them because we're applying the same script. So if it works for say 2 or 3 of them, it's safe. It's a safe bet to believe that it will work for all of them. And then once we verify that the admin machine can get into those, I will show you that the user machine cannot get into them because it's on a different subnet. If we were to move the user machine over into the admin VLAN, well, then it'd be able to get into the switches. Because then it would fall in the correct subnet. Alright, so let's go ahead and jump into the admin PC and let's log out of AS1. We're going to hit the up arrow in the command prompt window. Let's just jump into the Office core as our next device. So 172.16.0.2. Cool, it prompted us for a password. Otherwise, it would have said connection, something of this nature, like connection closed or connection canceled, something like that. So Cisco 123 bang. Okay, maybe I fat fingered it. There we go. Okay, so this is a perfect example. Closed by foreign host because I got the password wrong. Let's try it again. In fact, that's where I went wrong. Misspelled Cisco 123 Bing. Oh well, I'll just paste in this password just to kind of show you that it's a thing. All right. So I got in. So the script is correct, all with the exception of me misspelling Cisco 123 Bing. So everything north of AS1 will have to use that password. I could go back and change it. I'm not going to. You guys can do it if you want to, but I'm not going to. Don't care enough. All right. So we got into the Office core. See if we get to the DC core, which that is .6. I'm gonna paste in this password. Script's looking good. By the way, enable secret password is Cisco. We have that correctly. Got in the DC core, and then just we'll end it with LS1. Call it good from there on the admin PC. So what was that? 10.10.5. What would that be? .5, I think, or .4. I think it's .4. Yep. Good there. And we can get into everything. Like I said, everything except for that misspelled password, we're good. Now we will see if we can get into any one of these devices. We'll just go for AS1 because it's, you know, there on the user. So desktop, command prompt, same deal. We're gonna do SSH-L, Cisco capital C at the front for username, and then the IP of the target that we're trying to hit with SSH. So 10.10.5. I believe this was 36. And connection refused by remote host. This is what we will see if we are denied access because of that deny statement at the end of it. So this is pretty much the entirety of the topology. This is pretty much the configuration. Not too much going on with the hardening stuff because, like I said, we're limited with what Packet Tracer can allow us to do. Maybe we'll revisit that in a CML lab in the near future. But yeah, this is it. So pretty much from office to data center all the way through the campus router, we configured EIGRP through point-to-points. We redistributed our connected routes that we configured in our data center and office router. We verified that all of our endpoints with the admin machine, the user machine, and the printer can pull DHCP addresses from the DHCP server. And that will conclude our lab series for the day 0 to day 3 task. Thank you for joining me, and check out the next video.